Right, welcome everybody. How was lunch? Whoa. So are we all in the right talk? We are here to talk about how we as Microsoft have done our DevOps transformation over the past kind of 6, 7+ years. All in the right talk? Great. My name is Willy-Peter Schaub. I'm a program manager with the Visual Studio Team Services team and also with the ALM DevOps Rangers. You can contact me anytime at willys@microsoft.com or on Twitter at WP_Schaub. If you're wondering about my accent, or I always say in North America, the lack of accent, I was born in Basel, Switzerland. I grew up in Joburg, and I'm currently working out of Vancouver, Canada. Here are just a few pictures to kind of give you a hint of what my interests are when I'm not plugged into the digital world. So I love to explore the oceans, I'm fascinated by aviation, and I enjoy watching sunsets wherever I am. Now that is a problem in Vancouver because you hardly ever see the sun. But I'm actually enjoying it here back home. So I work on a thing called Visual Studio Team Services, and it's our collaboration system allowing engineering teams to plan, to track, to develop, test, release, and monitor, and also then obviously analyze the telemetry. And whether you're kind of targeting the cloud, the hybrid cloud, or on-prem deployments, VSTS is our recommended Azure DevOps solution for any language, any platform. And the next slide, which comes from our leader, our big chief, he wants us to use the tools that we sell the customers, which I think is a good thing. So he said, from now on, you will start using the tools that you sell the customers, and you will work as one. So it's been a huge culture shift within Microsoft. But it was enabled by VSTS, which you'll see as part of the roadmap. And VSTS itself is built and released by VSTS, and it's currently used by other teams such as Azure, Office, and Windows. And Windows was the last big team to join the One Engineering team, and they have a huge Git repository. Any estimates how big their Git repo is? Any guesses? How big should a Git repo be? Okay, you're not even close. It's 300 gigabytes. Right, but we're here to talk about the DevOps transformation. So the first thing I wanted to show you is our definition of DevOps, because everybody has their own definition. For us, it's the union of people, process, and products to enable continuous delivery of value to our customers. And there's a few things here that are very important. It's the continuous delivery of value. And in this talk, we will be talking about people, which is actually the most difficult part to get right as part of any DevOps transformation. Then while we're at kind of building our definitions, we also have our definition of done. Now, what is typically your definition of done? Go home. Well, usually it's when the code compiles. In our case, no. When you hand it off to operations and go home, no. For us, we're done when we are live in production and collecting telemetry that we can actually use to examine the original hypotheses that actually was the result, basically the point of the deployment. So we can now actually make a decision, was this a good or a bad feature that we pushed into production? So it's not just it builds, it links, it compiles, it deploys. I mean, in the past we used to have those metrics. Today we are actually looking at what does the telemetry coming back from the field tell us? Because that's the only time we will know, was it a good or a bad feature? So let's look at our roadmap. So we started in August 2010. That's a long time ago. We actually started with our journey, and we started by basically aligning our sprints. So that was really sprint one for everybody, and it was actually the same duration, 3 weeks, and everybody had the same naming convention. So we started with sprint one, August 2010. April 2011 is when the Rangers actually adopted VSTS as the engineering system. So basically they became the early canaries of the product. It wasn't even publicly available yet, and we were using it, and you'll see the canary there. You'll also see a yellow triangle in the corner. So keep an eye on the slides. I'm trying to highlight value back to the user, kind of with the triangle. And in terms of the canaries, we're obviously making sure that we suffer first, and we're the only ones to suffer. And any bad bug or feature that is not kind of ironed out yet does not actually end up in your environment. And you can see that 2014 is when VSTS went public, and it was also when we started our one engineering system. So that is when we started doing what Satya told us. You will use your own tool, and you will collaborate as one Microsoft. And during our transformation journey, we've basically focused on these 5 habits, 3 of which I refer to as a really agile plus, i.e. being customer-focused, having team autonomy, enterprise alignment, and the shift left, for me, is agile plus. And then we have 2 on this list, which are particular to a DevOps mindset, and that's the production-first mindset and the infrastructure as flexible resource. So let's actually look at the first one, which is being customer-focused. It's the simple stuff, like, first of all, listening to your customer. In the old days, we used to build features after feature after feature because we thought they're cool. Today, we listen to the customer. So, for example, here's user voice. We're getting feedback from the customer. This is the feature we need, and we actually see the popularity of the feature by the users telling it's good or bad. It's having a vibrant community and also being responsive to the community. So you have to obviously build a vibrant community, and if they have an issue or a question, we have to be responsive. So we have to be customer-focused. Then we also have something for our high-load customers. We allocate a champ from the engineering team, and that champ is the first point of contact for A, the customer, and B, the engineering teams. So that builds empathy and trust for all the stakeholders. And that's something I heard in the keynote as well this morning, is you have to have this empathy. And then obviously we also get feedback from within the product. What we also do, and that if you remember that the circle at the top, it said monitoring, we collect a lot of data. So there's a lot of telemetry being recorded, and we're actually recording up to 1 petabyte of data per day. And that's just the telemetry. And I just wanted to highlight, it's about 15 zeros behind the 1. So it is a lot of data. And what you can see here are just some graphs and data that we pull off the system using a tool called Application Insights Analytics, or it's also called Custo. It's a pretty cool tool, because obviously if you think 1 petabyte, there is a lot of data that we're actually scanning through. Now we use that data to track key performance indicators, or KPIs. And if you ever visit one of the engineering locations like Redmond or Vancouver or North Carolina, and you walk into a feature team, it looks like Houston Space Center. You'll see monitors showing kind of graphs and data, and it's really looking at key performance indicators 24/7. So things we look at here is usage. So what's the acquisition plan, the engagement, customer satisfaction. Again, Here we need to make sure how satisfied is the customer. The churn, do the customers join and drop off? It's a concern. And obviously which features are used and which features aren't used. Now this is an area you might actually get one of these occasional pop-ups to say, how satisfied are you with the product? Please respond. It's literally just selecting from 0 to 10. And if you do not give us a 10 out of 10, please also give us a feedback and a quick comment as to how can we improve it, so you will select 10 next time. It's important for us. For our engineering process velocity, we are tracking time to build, self-test, and deploy, and time to learn. So that's really analyzing the telemetry. And this is to ensure that we can actually keep our lead times and cycle times as short as possible for both features and bugs. And then lifecycle health, it's time to detect. So if something goes wrong, how long does it take for us to detect that something went wrong? Time to communicate. We have to communicate to the customers that are affected, and time to mitigate, which is obviously the most important. That's the key metric. And what's the impact on the customer? Things we don't watch anymore, and that's a conversation we just had a few minutes ago, is the kind of lines of code, which was very popular in the old days. We don't even look at that information anymore. Team capacity, burn down, team velocity, those are all things we no longer track because there's actually no value to the customer. Now, when we're looking at the performance of the system with millions of users across multiple data centers, it's not easy to stay in kind of the high nines, but it's also very rare that you will actually experience a complete meltdown of a data center. But what we do, and that's kind of where the outliers come in, is we measure our service level agreements or SLAs by customer and their experience with the system. So obviously we look at the overall, but we really focus on customer SLAs. And I really don't want you to try and even squint and read this. You can actually zoom into it when you get the deck afterwards, but it's just an interesting example of where the ops team actually found a low availability with one of our top customers, proactively notified them that something was wrong, and resolved the issue. That's really cool customer focus. And we can only do that because we have the data. Then another thing that I heard in the keynote this morning was kind of the hypotheses. And we kind of build, measure, learn. That's kind of the way we do things today. And it's really around measurable business, services, and usability value. So we form a hypothesis, and then we do an experiment. And we do that for every feature. And every hypothesis obviously has a delivery cycle, which you validate each hypothesis as well, and it's either proven, disproven, or inconclusive. So it's those three states. Now the key is to run and learn from as many experiments as quickly as possible, so you can maximize your learning, number one, and that you can actually influence the value that you're delivering. So it's not just kind of learning from what's happening, but as you push out more value or features, you want to influence them the right way. So the shorter the experiments and the more you can run, the better. Then we've actually, I mentioned it, we are using 3-week sprints, and we're using something called feature flags to fine-tune the user experience when the releases actually go out. Everybody know what feature flags are? Is anybody using feature flags? They're really awesome, but use with caution, because they do introduce technical debt. As you add feature flags to your system, you're actually adding technical debt. At some point, those feature flags are stale, and they need to be removed. When you tell teams to remove things, they say, later, it's working. So again, that is technical debt that you're accumulating. Be careful. And then I've just put a link there. You can read some articles we wrote about whether you should be using feature flags or rings or both, why they're good and they're bad. But here's an example. Feature flags are also great when you kind of have big launch events. So you can actually hide a feature just before your CVP, your kind of vice president, like Brian Harry, goes onto stage and actually announces a new feature. Well, we tried that. We tested it. He tested it. He was happy. We flipped the switch at the keynote, and it didn't really go well because you can see some spikes where systems in the back-end systems went down because we didn't really kind of plan for the load that was added to the system during the keynote. Again, be careful with feature flags. You have to test it, and that's the other technical debt that you inherit. Because if you have a feature flag, you've got two code paths, true or false. Or you can also have multi-value feature flags. You have even more code paths to test. So caution. So let's look at production first mindset, which is really the first one that is particular to DevOps. So we've got something called live-site incidents. So if you call Microsoft and you say your system is down, or it's really not running well, it's really slow, we refer to that as a live-site incident. And on detection, we create a conference bridge. So a call is fired up. Think of it as a Skype call. And then the DRIs, you can see we love TLAs at Microsoft, three-lettered acronyms. The designated response individuals, which are really the people on call, just say people on call, and the CHAMs, if there's a CHAM for the customer, he would actually be invited to the call as well. And key is to secure as much of the evidence as possible and to mitigate the issue. And what you'll see there is 5 to 15 minutes. During business hours, we have 5 minutes to join the call, and after business hours, we have 15 minutes to join the call, and the call stays up until it's mitigated. So if it kind of takes too long, then obviously the DRIs or the people on call are kind of rotated because kind of the moods change after a few hours on the call, and also the effectiveness of the people on the call kind of diminishes over time. So we have that. Repair items, very important. Out of any incident that happens, we have repair items. They are added to each of the feature team's backlog at the top, and they get 2 sprints to sort them out. So they're very high priority. And we kind of create them so we can recover quicker in future, and that we don't run into the same problem again. I'm sure you had that scenario as well. I fixed this thing before in production. And again, you'll see a kind of a small triangle there. This is not really a value to the users, but because of this, engineers produce much better code. That's kind of the learning we had, is they don't want to be on these calls. They don't want to be woken up at 3 in the morning to join a call. And they definitely don't want to have to report back to management why they were on the call. So we found that with the kind of introduction of these official bridge calls, the quality of the code started improving. And key is, if you have a problem, be transparent. So we try and be as transparent as possible with what went wrong, because we believe that if you have an insight into what was actually happening, you have a lot more understanding. And again, transparency is not easy, but it builds empathy and trust. And again, it goes back to the keynote of the empathy part being very important for users. Alerting was the other thing. We invested in alerting. We switched on alerting, and it was terrible. I remember the days when the Rangers switched on alerting. I had dozens of emails every morning, and it's kind of, no. So it's like I'm sure you heard your neighbor's car go off every time a car drives by or a squirrel runs across its bonnet. You start looking out once or twice and then you start ignoring it. Exactly that happened with us as well. We started ignoring the alerts. So we had to invest time to fine-tune the alerts and make sure that they are actionable. So instead of giving me 25,000 alerts, give me one which is actionable, and many of them are also now automatically calling the people to those, calling the DRIs to those incident bridges. So this is key, automate everything. If you read Buck Hodges' blog post, there is no partial automation. So if you're sitting on a live site incident, what you really want to do is just quickly put a fix into production, make the customer happy. No. Every kind of command we now run in production has to go into a PowerShell script, which is checked in. Now we have traceability. But it also has to go through the normal cycle kind of process. So it has to go through release management to be deployed to production. Because if you do it manually, you're going to forget that you did it, and the problem's going to come back next time. Then we've actually are also using, together with feature flags, the ring deployment model, where we deploy into rings. And in the first ring is where the entire VSTS team lives, where the Rangers lives, and a few early adopters live. So any release that goes out first goes to the canary ring. So let's call it the canary ring. And if the miner with the canary in its cage is saying everything's fine, it will go to the next ring. Again, for me, that's valuable because, and the reason I put the triangle there, because we have pain, you don't. By the time it gets into your ring, we have actually ironed out most of the wrinkles. So in this case, ring 1 said canary. If that works, we kind of do this normal testing deployments. We go into ring 2, which is the smallest external data center, then into the ring 3, which is the largest data center, ring 4, international data centers, because they have all the latency issues. And then ring 5, which is just about everything. So think of North America going into one bucket. And then there's the other thing we use are circuit breakers. So in production, we rely heavily on circuit breakers to kind of monitor the load of the system. And they're just about the same as any circuit breaker at home. You want to monitor your kind of surges before they turn into fires. And again, there's a link on the slide if you want to know more about them. This is really cool. Something I recommend to any organization doing this journey. We have a red and a blue team. Some of the best engineers are in these teams. We don't really know who's who. But the red team is continuously attacking our system. They are sending out these weird emails that look like these phishing emails. And you always wonder, is it one from the red team, or is this now come through the firewall? And the blue team is obviously there to continuously defend the system. And those two teams are just having constant battles, which is great, because at the end, they call us the entire team together, and full disclosure, they will actually share all the tactics they used and all the lessons they learned. They actually found a lot of passwords in scripts and on file shares. So the learnings are sometimes also a bit shocking. Right, so that was production first. Now the big one is team autonomy and enterprise alignment. So this is the teams, the people. And I mentioned this is the worst one, or the most difficult one. It's not the worst one, it's the most difficult one. Now there's a great book for you to read, and I'm sure most of you have read it. It's called Drive, and there's also a cool video. And it talks about what really motivates you and I. And it's not the money, it's kind of the autonomy, purpose, and mastery. It's really having a purpose as part of the system that you're part of. However, we also have to kind of have a fine balance. We cannot have anarchy within our teams. So we balance the team autonomy with alignment with the business, and that's really where the business process comes in, and the team autonomy is you have to have a fine balance there, otherwise you go into anarchy. And let's just talk about an example of having too much autonomy. So this is our Windows team. They were told this is just before they were told to join the One Engineering system. They were trying to move from multiple product studio accounts to one, and that's an internal tool. They had a 1-year migration plan. Then somebody decided, no, you will join VSTS and you will get 2 weeks to do it. Okay, pop quiz at the end, did they actually do it in 2 weeks? What happens when you turn something from 1 year into two weeks? You get some of these really weird requests coming through, and unfortunately, everybody just says yes, because I don't actually have time. Yes, we'll do it, which results in a work item like this. I don't know if you've seen this before. Every sticky note is a field. And if this is not enough, we can scroll down a bit and see that there's more. We then looked at their state models, and it was just as horrific. So this is all the technical process state that they built as part of that quick migration. So we actually looked at how much time does a developer spend delivering value. And the part that is kind of not dimmed out is just close to 50% was actually spent on working, kind of fiddling and manipulating work items. So the developers were only 50% efficient. They were only able to build value half of their time. So what Windows did when they kind of realized this, they created a Jedi Council. They brought leads from all the engineering teams, and they started kind of decreasing the process debt that they created afterwards. I recommend that you actually do it before. It's much easier. So let's talk about another way how we organize our teams. And this is something that is now common across all engineering teams at Microsoft. So we started off with program management, development, and testing. I'm sure you recognize this picture in many of your organizations. What we did is we got rid of the last two, development and testing. We got rid of them, and they all became engineers. So we no longer had developers and testers. They were now called engineers, and they were responsible for the feature, for development, testing, deploying it to production, getting telemetry, analyzing it, and making sure it's a good feature. I'm not saying that all engineers do everything. Some of them are obviously more biased towards development. Some are more biased or experienced with testing, but they are responsible for their features from beginning to end. And then also the next step is obviously we don't want engineering to just throw things over the wall and say, oops, here it is. So we went one step further and we built feature teams. And the feature teams are now responsible for the customer experience in their area. Nobody else. They're on the hook for their features, their experience to the customer. So they can't actually throw anything over the wall anymore. They actually have to deploy it, and they have to support it. Now, if you go to any of our dev centers, this is a picture that was taken in Redmond. They're all physically located in a team room, which is surrounded by small meeting rooms and chat rooms. But the key point here is they are together. So the feature teams are together. Again, something I heard in the keynote this morning, it's far more effective if your team's together, which is a problem with the ranges because we are geographically distributed around the planet. So if we work on a project, you can have multiple time zones involved. You can imagine what that does to communication. The teams are cross-discipline. The size is about 10 to 12. They're self-managing. They have their goals, and they stay intact for about 12 to 18 months. And they own their feature. Again, I have to emphasize, they own their feature and the deployment of features. So our feature teams own the entire feature all the way through production and all the way through the stack as well. So this is a big change that happened as well, is we actually want the teams to own the feature right through, both through production and through the stack. Now I mentioned that the teams are intact for about 12 to 18 months. So after that period, what happens is we have this sticky note exercise. So we will actually introduce a new project, the new features, the new ideas. Every program manager will actually put up and sell his kind of new vision. And every engineer will get 3 stickies. My first choice, second choice, and third choice. And they will select which team they would like to work on going forward. So they get a choice. So what it does is it gives every engineer the choice of what they want to work on. And it gives them the sense of purpose. What we find, however, is that there's only about a 20% change. Most of them actually stay in the team they've been working in. Now, this is scary to kind of senior management, is that the engineers actually pick the projects they work on. But again, in the keynote, it was emphasized, you get more productivity if you actually have the choice. Right, when we start doing planning, we have the 18-month scenario. That's for us is the North Star. Then we have a season, which is kind of what we think we were going to be doing. And our confidence of what we will be delivering is about 40%. So it's kind of really envisioning. And then we plan everything in 3 sprints. So we always plan 3 sprints ahead. And obviously then we have the sprint we're working on, where the confidence should be accurate and close to 100%. I'll say close to 100% because there's always a bit of doubt whether you can deliver what you've committed to in a sprint. The leadership, as it says, is responsible for the big picture, and our feature teams are responsible for all the rest up to the 6-month season. So they take full ownership. So if we look at a quick model, we always plan the 3 weeks in ahead. So if we start working on a sprint, again, we always have the plan for the next 3 sprints ahead, and so on until we get to the end of the season. And when we get to the end of the season, we plan the next season, and we kind of adjust the North Star as well. It's continuous planning. This is where I'll bring this one up, which always leads to a kind of a debate afterwards. So if you want to discuss this after the session, I'm happy to. But we believe that a plan is no longer useful. Those 100-page specs, put them through the shredder. What is really valuable is continuous planning. Much more valuable. Here's just a graph, because what you'll see is that the majority of the value is achieved early. So if you look into your value streams or your value chains, you will see that most of your value is actually realized very early, and it kind of levels off with long-term planning. So what we try and do is actually focus on the high-value period and get rid of that long-term planning, and we just keep doing this over and over. And if you put these graphs next to each other, you can visually see that you end up delivering more. So this is where continuous planning is really effective. Right, big questions is how do we stay in sync? Because kind of if I have big teams, we have the one thing which is every feature team within VSTS creates a sprint email at the end of the sprint. And the DL of those sprint emails, as it says, there's about 930 individuals receive that sprint email. And the sprint email really gives you a retrospective of what happened in the past sprint and what the team is planning going forward. And always not always, there should always be the technical debt as well, and obviously the dependencies. But we rely on this email going out. Here's just an example of one of those emails. They're typically very short. And the good ones actually have a sprint demo video or more than one video in there as well. And the best ones are about 2 or 3 minutes, so keep them very short. If you get a sprint email with lots of text and 2 videos, what do you actually look at? The video. Personally, I just look at the videos. Brian Harry, I know, always looked at the videos first because he always came back and said, at that time, what is happening? So he literally looked at every sprint demo video that was distributed by the team. Then every 3 sprints, we have something we call the team chats. And what really happens in those team chats is the teams talk about what's next on their backlog, what's their debt situation, are there any issues, any dependencies. So that's where we identify dependencies between teams. And most importantly, it happens with all the teams in the same meeting. So we usually have 3 meetings of 2 hours each, and we invite all the feature teams, and the leadership sits there as well. So nothing gets lost in translation. And again, you see the picture of transparency is important. Then when the season ends, we have something called the experience reviews. And there it's really looking at storyboards of customer experience, high-level execution plans, sprints, not hours. So it's not granular reviews, it's really very high level. And it's the time that the feature teams get feedback from the other feature teams. So I think what I wanted to highlight there is that collaboration is important, transparency is key. And kind of the benefits that we found with the feature teams is they really feel empowered because they have autonomy and they have ownership. They own the feature from beginning to end. So until that feature flag is flipped to say off and it's taken out of the code, they are responsible for it. And they're continuously planning and they're empowered to deliver value. We don't just empower them, but they are actually empowered to deliver value. All right, so let's quickly look at shift left quality. We have something else we call it the bug cap. And again, you can see the yellow triangle. Engineers are allowed to have 5 bugs, which means if you have 10 engineers in a team, they are allowed to accumulate up to 50 bugs. As soon as they hit that limit, they stop working on new features. They have to fix or resolve their technical debt. Why is that valuable to the customer? Well, developers hate working on bugs. They want to deliver features. So they very seldom these days actually hit the bug caps. This again is looking into the past. You have these cycles of debt that build up when you build a thing. Then you go to stabilization phases. And I just put the TFS 2010 kind of spikes of bugs there as well. What we saw in the past, there were always these spikes of bugs whenever we went into stabilization. And there was a lot of teams playing this, what we call the chicken checking game. If I'm not done with my feature, I just check it in. Because somebody will raise a bug after code freeze, and then I can actually finish my feature by fixing the bug. Have you seen that? That's why we always had these big spikes of Himalaya kind of bugs being accumulated. This is how it looks today. So the teams effectively manage their bugs, and it's usually ripples of bugs. They kind of squash them. It's like this, I don't know what that game is called, where you squash the crocodiles as they pop out. That's kind of how they work. So this is our learning of how the teams actually adapted to this whole gaming, because we don't want them to game. We want them to deliver value. Then we looked at our test portfolio. I think that's one of the discussions I had earlier or last week with colleagues is kind of the testing. Well, when we looked at our test portfolio, it was scary. Most of our tests were actually of these L3 types, which are kind of fully automated user automation testing. They were brittle, and they were long-running, they were expensive. So we wanted to actually switch or shift left. This is where the shift left comes from, to go to L0 and L1 type tests. And I just put kind of the graph at the bottom where you can see that over the sprints, we pivoted to L0 and L1. And really the intent was that they are fast, they are reliable, and that they could actually be part of pull requests. So talking of pull requests, we use pull requests to enforce the L0 and L1 tests. So they always run with every pull request. Other validation scanning is running. And I think, yes, the last time I checked, 71,283 tests run with every pull request. And they have to run within kind of 1 minute per 10,000. Otherwise, Bug Hodges again gets kind of excited and he makes calls to teams and says we have to make things better. So you can see it, we take 6 minutes and 35 seconds to run those 70,000 plus tests. Now this is valuable because the days of he broke the build or she broke the build are over. You cannot break the build. You can break your pull request build, kind of your validation build, but not the build going into production. Why is that important? It's important because we actually work off master. There are no Q&A branches, there are no development branches. Everybody works off master. You start working on a bug or a topic or a feature, you have a short-lived feature branch off master. If we want to deploy the next release, that's when we branch off master. When we start working on bugs, we fix them on master, not the release. And then we cherry pick the fix into the release. Why are we doing that? Well, if we don't do that, the bug's going to hit us again in the next release. But what's very important on this picture, which is coming up now, is everything going to master is protected by pull request. So that is where we can make sure that master is our single source of truth. Right, and the last area that I'm going to touch on is infrastructure as a flexible resource. And this is our next area of maturity where we're going and getting better. So I guess when you hear this talk in a year's time, this will be the big area of focus. And gone are the days, as it says, of dragging several laptops and dongles and external drives and whatever to an event like this, because we've moved everybody to the cloud. So there's less heat under the tables, there's more leg room, and every engineer has access to more power, more scalability, and most importantly, it's consistent. It's not the way Willy installed his TFS server under the desk and the way that Zaid installed it and it works on the one and not the other. It's consistent. The other big thing that we have done and we are continuously improving is we went from a monolithic code base to a service-oriented architecture. And that was really driven by VSTS. So we have a shared platform services such as account, identity profile, and licensing, and regional scale units. And then we have a few services running out of containers, and you'll see more of those moving into the container space. Right here, I just wanted to say if we would do this all over again, we would probably consider a platform as a service to start with, Service Fabric and Azure Functions, and ship the same code base to on-prem and the cloud. And here we're saying the same, because at the moment we share the code base, but it's not the same. And also we're moving to containers, as I mentioned, and that's to raise redundancy and scalability and lower cost. Right, and this is a magical moment because the DevOps journey is one of continuous learning and improving. It's not about rainbows and magical unicorns. And what's really important is do not take what I've just shared with you very quickly. This was actually a condensed version of what is usually a 2-hour talk, which is a condensed version of about 2 days worth of videos that you can pull off our website. This is not a blueprint. It's not a silver bullet. this works for us. It works for VSTS, it works for Windows, it works for Azure. It may work for you, but it may not. So please do not think this is a silver bullet. So we've still got a lot to learn, and we keep making mistakes, but we've come a long way. This is kind of reading for you afterwards. This is just a summary of kind of the story so far. Just highlight the first and last. So we went from 6-month milestones to 3-week sprints, and instead of shipping features every year, we ship them every 3 weeks now. And in terms of Ring 0, we ship them daily. So bugs also are shipped daily. And a quick summary of the ranges. This is our open source community. They went through this similar process and again had some really good results coming out. What I did try is to summarize this journey on 2 quick reference posters. I've got 2 there. So if you would like a physical copy, grab one. If you would like the digital copy, drop me an email. I really just tried to put the 5 habits onto a poster. It's like a cheat sheet. And so you have a quick reference as well. There is a planning one, but again, the planning is how we do the planning. It's not necessarily how everybody else will do their planning. And if you want a real demo, ping me. I will literally show you our VSTS production environment, or the Rangers production environment. I will show you how we plan, how we show things, how we break it down. Again, we just did not have the time in this session to do that, but if you would like a demo, ping me. You can do it today, or we can also do it over Skype. Then this is a result of having kind of time zone problems and not sleeping when you should sleep. I tried to define the nutritional facts of DevOps, and the only really interesting parts are, again, those yellow triangles, which I think this is where the key value sits. With that, thank you. I've put a few AKA links there for you to look up the details of what I shared, and also the contact details. Thank you. Yep. Yeah, it's mock-ups. The mock-ups are really PowerPoint storyboards. So this is where you kind of visually show how you think the feature sits together. This is also where the requirements would go. I'm not saying there will be no documentation. We're saying there are no 100-page detailed specs anymore. What we do is we have these storyboards, which we then bounce off other feature teams and also users to say, is this really what you think you need? And yeah, we use PowerPoint. It's much easier than Word. And the Rangers, as you know, they create prototypes. So we just put together a working prototype, and we actually show that to the customer. Any other questions? Yes. Okay.